You don't have to look very far to be amazed by Mother Nature. Hard to believe, both this fish and I require the same essential things for survival, like oxygen. But while I can clearly breathe in this precious gas, can you think of how our aquatic friends get their quota? Join me for a chemistry session to learn more. Hello and welcome to another interactive session of chemistry. Today we will be studying what intermolecular forces are. Then we will learn about the van der Waals forces such as dipole-dipole forces, dipole-induced dipole forces, and dispersion or London forces. And finally, we will put these forces to work in acing the exams with exam decoded. Think back to your earliest memories of studying science. I am sure you will recall being taught about the states of matter, that is, solids, liquids, and gases. The good news is that today's lesson will take you back to those basic concepts. The better news is that we will be uncovering the scientific reasons why these states occur and behave the way they do. Let's begin with the most basic substance, water. We all know that its chemical composition is H2O. Then why does it exist in different physical states as ice, water, and water vapor? To answer this, we need to delve into the molecular structure of water and study its intermolecular forces. These are the forces of attraction and repulsion between interacting particles. How do you think these forces affect the different states of matter? Keep thinking. Intermolecular forces of attraction are strongest in the solid state, which explains the compact packing of molecules. These forces decrease in liquid state and they are the weakest in vapor state. Such intermolecular forces of attraction are known as van der Waals forces. These forces were named in honor of the Dutch scientist Johannes van der Waals. Let's see how many types there are. There are three classifications of van der Waals forces: dipole-dipole forces, dipole-induced dipole forces, and dispersion or London forces. What is this term dipole, you ask? Let me explain. A covalent bond is formed by sharing of electrons between two atoms. When two dissimilar atoms form a covalent bond, the electron cloud gets distorted towards the atom, which exerts a greater pull. This property of pulling the shared pair of electrons towards itself is known as electronegativity, and the resultant bonds are called polar covalent bonds. Examples of polar covalent bonds arising because of the difference in electronegativities are HCl, HF, etc. When a molecule is formed by two atoms, one end becomes positively charged and the other end becomes negatively charged. Thus, a partial positive charge is developed on the less electronegative atom and a partial negative charge is developed on the more electronegative atom. Such an arrangement is known as a dipole. If you are having trouble imagining it, remember that it is a lot like a cell that you use in daily life. Just like a cell has a positive and negative end, so does a dipole. Dipole moment is defined as the product of magnitude of the positive or negative charge and the distance between the charges. If we were to multiply the magnitude of the charges developed with the distance between them, we would get dipole moment. The most important significance of dipole moment is that it measures the degree of polarity. It also tells us about the nature of molecules. Molecules which have zero dipole moment are non-polar in nature, and the molecules which have some dipole moment are polar in nature. Let us now move on to two different kinds of dipoles, permanent dipoles and temporary dipoles. Dipoles that have permanent dipole moments are called permanent dipoles, and dipoles having temporary dipole moments are called temporary dipoles. A good example of this is hydrochloric acid. Why is this so? This is because of the electronegativity difference between hydrogen and chlorine. Since in HCl, the electronegativity of chlorine is more than that of hydrogen, the electron cloud will be pulled towards the chlorine atom. A partial positive charge will be developed on the hydrogen atom and a partial negative charge will be developed on the chlorine atom. This arrangement is called a dipole. Now that we have understood the meaning of dipole, let's move to the first type of van der Waals force, that is dipole-dipole force. When dipoles such as HCl approach each other, the molecules align in such a way that one molecule's positive end, that is hydrogen, approaches the negative end of the other molecule, that is chlorine. Since the charges present have a magnitude that is less than unit electronic charge, they are called partial charge and are denoted by delta. And since both molecules have permanent dipoles, the force between them is called dipole-dipole force. Now let's look at a special type of dipole-dipole force which is exhibited by hydrogen bonding in molecules like water. Hydrogen bonds are defined as the attractive forces which bind hydrogen atoms of one molecule with the more electronegative atom of another molecule. Hydrogen bonds are formed in polar molecules. Take a closer look at the hydrogen bonds that exist in water and ammonia individually. And between water and ammonia. They have strong hydrogen bonding due to the high electronegativity of oxygen and nitrogen. Dipole-to-dipole forces are also the reason why polar molecules are soluble in polar solvents. For example, the polar molecules of glucose are soluble in water, which is a polar solvent, and not in hexane, a non-polar solvent. To understand the impact of this force better, take a look at these two bottles of water. They both contain the same amount of water. But look what happens when one of them is placed in a freezer for some time. The water in the freezer seems to have expanded. Why is this? This expansion can be attributed to dipole-dipole forces. When water forms ice, it forms 4 hydrogen bonds with 4 water molecules, which gives rise to the structure you see in this figure. When the ice melts, this ordered structure collapses. So for the same mass of water, ice has a larger volume and seems to expand. Well, it's that time again. Yes, I'm talking about the break. So as always, get ready to answer this question. Why is HCl a gas at room temperature and HF a liquid? Join me on the other side for the answer. Welcome back. Before the break, I had asked, why is HCl a gas at room temperature while HF is a liquid? Well, this is because fluorine has greater electronegativity than chlorine. So, hydrogen bonding will be stronger in HF as compared to HCl. And as you know, in gases, the bonding between the molecules is weak, and in liquids, it is stronger. Since this bonding is stronger, it exists as a liquid at room temperature. We have studied cases where both molecules have permanent dipoles. But what happens when one of the molecules lacks permanent dipole moment? Such molecules are called nonpolar molecules. This brings us to the second type of van der Waals force, known as dipole-induced dipole force. When a polar molecule with permanent dipole is brought in the vicinity of a nonpolar molecule, it distorts its electron cloud. This means that dipole moment will be induced in the nonpolar molecule. This type of force is called dipole-induced dipole force. If you are having trouble understanding this, just recall what you know about magnetism. Imagine an iron nail that is non-magnetized. What happens when it is brought near a magnet and exposed to it? That's right, the neutral iron nail becomes polarized and starts to behave like a magnet as well. We can say that magnetism has been induced in the iron nail. Inducing dipole follows similar principles. For instance, this type of force exists between hydrochloric acid and a hydrogen molecule. Now the question arises, can dipole be induced in all molecules with the same ease? No, because this phenomenon depends on two factors. The first factor is the dipole moment of the molecule possessing permanent dipole. The greater the dipole moment, the easier it is to induce dipole. The second factor is the polarizability of the molecule lacking permanent dipole. Polarizability is the ease with which the electron distribution in the nonpolar molecule can be distorted by the polar molecule. Larger the size of the molecule, greater is the ease with which its electron cloud can be distorted. Why? Because larger distances reduce the force of attraction between the nucleus and outer electrons. This brings me to the question I had asked you earlier about how oxygen is made available to fish underwater. Oxygen is not just present in the atmosphere, it is also present in water bodies like sea and oceans as dissolved oxygen. This dissolution happens when the polar molecules of water induce dipole into the non-polar molecules of oxygen. This introduces attractive intermolecular forces between water and oxygen, allowing oxygen to dissolve easily. So far we have studied instances where at least one, if not both molecules possess a dipole. But sometimes both molecules lack dipole moment. That's when the third type of van der Waals force comes into play, known as dispersion or London forces. London forces? Do you think it is because they were discovered in London? No, actually Fritz London is the name of the scientist who discovered these forces in 1930. So let's see exactly what happens in nonpolar molecules. Due to momentary imbalance of electron cloud, instantaneous dipole may be developed in one of the molecules. This instantaneous dipole distorts the electron density of the other molecule. This kind of intermolecular force is called London or dispersion force. Such kind of force are extremely weak and short-ranged. Since dipole is induced in this case, the dispersion force depends on polarizability and the size of the molecule. Sounds familiar? Well, it's exactly the same as what's observed in induced dipole force. Due to London forces, non-polar substances are able to dissolve in non-polar solvents. For example, benzene, an organic non-polar compound, is soluble in hexane, which is a non-polar solvent, but it does not dissolve in water, which is polar. Up until now, we have been focusing on attractive intermolecular forces. But molecules also exert repulsive forces. It's important to study this aspect because it is this force that prevents solids and liquids from compressing further and losing their physical character. Let's take a call from a student who would like to know more on this subject.
I don't understand how the repulsive intermolecular forces are related to the compressibility of solids and liquids. Can you explain that to me?
I definitely can. When molecules are packed in either a solid or a liquid, they are held together by forces of attraction. That means there are repulsive forces at work which prevent the molecules from getting too compressed. These forces occur due to the repulsion between the like charges of two nuclei and between two sets of electron clouds of two different molecules. I hope that answers your question. Well, in that case, it's time to take a short break. But get ready to face the full force of exam questions when I return with Exam Decoded. Welcome back to our discussion on intermolecular forces. We have been studying how molecules of various substances come together to form solids, liquids, and gases, and here are some of the important points. Intermolecular forces can be both attractive and repulsive. Attractive intermolecular forces are called van der Waals forces and have three classifications. The first type are dipole-dipole forces that exist between polar molecules. The second type are dipole-induced dipole forces that exist between polar and non-polar molecules. And the third type are London forces, also called dispersion forces, that exist between non-polar molecules. Hope you have bonded strongly with these important facts because now it's time for Exam Decoded. Exams can be stressful because you are expected to pack in a year's worth of study into a 3-hour paper. Luckily, Exam Decoded is committed to helping you take on this all-important task. So why not begin with our own version of the exam paper? I promise you, it won't be half as nerve-wracking. So let's learn the rules for the rapid fire round. This round has 5 questions which are to be answered in under 5 seconds each. You get 1 mark for each correct answer and I will be analyzing the total at the end. Shall we begin? Here is the first question. Which type of intermolecular forces exist in carbon tetrachloride? A. Dipole-dipole force. B. Hydrogen bonding. C. Dipole-induced dipole forces. D. Dispersion forces. The correct answer is D because carbon tetrachloride is non-polar. Your second question is, which type of intermolecular forces exist in ammonia? A. London forces. B. Hydrogen bonding. C. Dipole-induced dipole forces. D. Dispersion forces. We covered this in the earlier discussion. The answer is B. Hydrogen bonding. The third question is, the ease with which electron distribution in a molecule is distorted is called A. Dipole moment. B. Polarity. C. Polarizability. D. Dispersion forces. The correct answer is C. Polarizability. Your fourth question is, state if true or false. Iodine, a non-polar compound, is soluble in hexane, a non-polar solvent. The right option is true. For your fifth question, we have another true or false statement. Dispersion forces are the weakest intermolecular forces. True or false? The correct answer is true. That was the final question of the round, which means it's time to total up your scores. If you have scored 5 on 5, then you are a high flyer. Congratulations! Your exam strategy is working well, so keep it up. If you have scored 4 or 3 on 5, then you are an achiever, which is an encouraging sign. You can score even higher marks by revising today's topic at least a couple of times more. If you have scored less than 3, then you are still a learner and perhaps you need more help in understanding today's lesson. Well, worry not. We have just the thing for you. Log on to www.topperlearning.com, avail of the expert tips and practice tests, and I'm sure you will achieve good results. Well, good results can also be achieved if you know the kind of questions that will appear in the exams. Let me tell you that today's topic of intermolecular forces is part of the unit States of Matter, Gases and Liquids, and accounts for 4 marks. This makes it an important chapter to revise. The probability is that you will get short answer type questions for 2 or 3 marks. And you better be strong in your understanding of the concept because these questions will test your conceptual ability. So you won't just need to remember the concepts, you will actually have to learn to use them. Here is a good sample of a 3-mark question that examiners frequently ask. Arrange the following molecules in order of increasing strength of intermolecular forces. A, F2, B, Cl2, C, Br2, D, I2. Let's find the ideal answer. The first step is to identify what kind of forces are present in the given molecules. Since all the given molecules are nonpolar, therefore the intermolecular forces present in them are dispersion forces. This identification will fetch you half a mark. Now you must state that the dispersion forces depend on the polarizability of the molecules, which in turn depends on the size of the molecules. This gets you another half mark. Next, arrange the elements according to their atomic size, which you should recall from the periodic table. So, we have in increasing order fluorine lesser than chlorine, lesser than bromine, lesser than iodine. This will give you half a mark more. From this order, we can imply that polarizability increases in the order F2 less than Cl2 less than Br2 less than I2. This gets you 1 mark. For the remaining half mark, you must state conclusively that dispersion forces increase in the same order as polarizability. One tip I want to give you is to be thorough with the periodic table because, as you have just seen, it is a crucial part of many such questions. For other tips, let's join today's expert.
Today you have studied states of matter. Under this we have covered intermolecular forces. Please remember, dipole-dipole interaction is the force of attraction between polar molecules. Water is a polar compound and is a universal solvent. Please remember that the hydrogen bonding in water is the force of attraction, which is van der Waals force.
That brings us to the end of today's discussion. Isn't it amazing how the most commonplace occurrences like the freezing or vaporizing of water have such complex phenomena behind them? I do hope that besides memorizing these concepts for the exams, you learn to appreciate the truly wonderful miracles of the chemical world. Keep seeking, keep studying.